Hello everybody in Algebra 1. I hope you are having a good morning so far. I just wanted to remind you that you do have an assignment that will be due on Monday. Please check the sideboard for that. And after you get finished listening to today's lesson, your job will be to work on it and hopefully not have to take so much home for homework. The assignment that was due today, hold on to that. On Monday, I will check that in for you and we will take some time to answer some questions on that. All right, that being said, yesterday we were talking about properties of inequality, inequalities, and today we're going to work on the properties of inequality so that we can not just graph inequalities, but so that we can actually solve them. Okay, so basically we have two properties of inequality the way that your book sees it. We have the addition property of inequality and the multiplication property of inequality. Now I have add subtraction in parentheses here because really these work for adding and subtracting. And in a nutshell, to paraphrase the way that this is stated, the addition property of inequality just says that it's okay to add the same thing to both sides of an inequality, and it doesn't change anything about the way the inequality sign goes. You can also add negatives to both sides, so rather than splitting it out into the two properties, the addition property and the subtraction property, this particular curriculum just says we call both of them the addition property. However, it may help you in your thinking to think, okay, it's okay to add or subtract the same thing from both sides of an inequality, and the value won't change. Multiplication and division are somewhat similar. Now, there is a little extra thing we need to consider with multiplication and division, and that is you can multiply both sides or divide both sides by the same thing and it doesn't change the inequality unless we multiply or divide by a negative. And I want to show you some examples of how that works so that you can understand a little bit better. So on your notes sheet, we have 4 is less than 12. Everybody would agree that 4 is less than 12. And what we want to consider is, well, what if we added the same thing to both sides? Okay. Well, if we add 3 to both sides, okay, we get 7, we get 15, and 7 is still less than 15. So adding something, the same thing to both sides doesn't change the value at all. You could pick whatever number you wanted to put in there, whether it be positive, whether it be negative, regardless of what number you pick. I could pick, for example, I could pick -8 to add to both sides. I would have -4 is less than 4 that way, and still we haven't changed the value because we added the same thing to both sides. Same thing works with subtracting. You could think of whatever number you want to subtract, something difficult or something easy. I subtract 1, I would get 3, I would get 11. It still comes out to be less. Nothing has changed about the direction of the inequality sign. Multiplication and division is the part where we get possibly a little something interesting happening. So for example, if I have 4 times 3 and 12 times 3, you get 12, you get 36, still less. But if I turn that around and I did 4 times -3, 12 times -3, I have -36, and I have -12. The way that we think that through is think about owing money. It is better to owe $12 than $36. So when you multiply by a negative, it flips the inequality symbol over. Okay, let's take a look at dividing. Here's 4. 4 is still less than 12. If I divide by a positive number, such as 2, I get 2, and I get 6, and it is still less than. 4 is less than 12, 2 is less than 6. However, if I divided, instead of by positive 2, I divided by negative 2, I'd get negative 2, I'd get negative 6, and all of a sudden, it turns over to be greater than. So the properties of inequality say that it's okay to add the same thing to both sides, it's okay to subtract the same thing from both sides, and it doesn't do a thing to the inequality sign, whether it's positive or negative. If you have multiplied or divided by a positive, it doesn't do anything to the inequality sign, it stays the same. But if you multiplied by a negative or you divided by a negative, it flips that thing over. And let's take a look at the formal way of wording that. If A and B and C are real numbers, since we're in Algebra 1 now, we have to think about it in terms of how it really would be stated, such that A is less than B, then A plus C is less than B plus C. That's the way that works. In a very formal way, we would also have to make a qualification that, well, actually no qualification on that, it's the multiplying one. So no matter what C is, you can add it to both sides and it will work. If you are thinking about multiplying or dividing, if A is less than B and C is greater than 0, it's positive, then you multiply by both sides and it still is less than. If C is negative though, this is when multiplying both sides by that negative is going to turn it over to make it positive. This is the same as for division. Technically, dividing is simply just multiplying by the reciprocal. So once again, your textbook company decided that you don't need to actually have that as a separate rule. So what it's used for, though, what it's used for is to be able to solve problems like this, okay? Just like we were using the rules for equations, when you're figuring out how to simplify these, pretend they're equal signs, but then just watch out for if you had to multiply or divide by a negative. So what do we mean by that? What we mean, for example, if I'm looking at our first example here, okay, think for a minute, what do you do to both sides? Hopefully you all thought of I need to subtract 6 from both sides. So if I subtract 6 from both sides, nothing happens to the inequality, it stays the same. We're left with x over here. This cancels. Negative 2 minus 6 is negative 8. So x is greater than negative 8. If we need to graph it, 8, 9, 10. All right, before I write it, think, okay, will I be having a negative, open circle or closed circle? And probably half of you are saying, wait a minute, they have to be negatives. And yep, they do. Let me fix that. So negative 8, negative 7, negative 6, negative 9, negative 10. And by now you should have decided that this will be an open circle because there's no extra equals there. And x is on the bigger side, so that would be over here. Okay. Looking over here, consider what you would do to both sides if it was an equal sign. Well, we would multiply by 2. Notice that we multiply both sides by positive 2. Since I multiplied by a positive, my inequality sign stays the same. Doesn't matter that this is a negative. It does not flip over. Just because there was a negative already there because I multiplied by a positive to solve. So I'll have x is less than -2. So in terms of graphing, do check the directions though. If it says just solve, you can just finish with solving. But I just want to put in these graphs here because you can't see too much of it. Once again, there's no extra little line, so we have an open circle. The smaller side, the numbers that are smaller, -3 is smaller than -2. -4 is smaller than -2. So that's over here. Make sure you color it in. Make sure you color the arrow to show me that you know that it's going on forever. Okay. Here, this is the not equal to sign. But pretend it's an equal sign. Okay, so I need to take away 3 from both sides, which you probably had already thought up. This cancels out. X not equal to -4. Let's consider the graph. -4, -3, -2. There's no set rule as far as how many numbers that you have to put on. However, I'm just going to say, make sure you put at least 2 on one side and 2 on the other side. So it can't be 4, but it can be all of the other millions and millions and billions and trillions and an infinite number of numbers over here and all of the numbers over here. So really, literally, this graph is of everything except not -4. Okay, now, this one doesn't need to be very difficult. However, I do know from experience that sometimes this one confuses people a bit. As far as what to do to both sides of this, okay, many of you probably thought for a minute you would multiply by 3, and that's not wrong, but I'm going to say let's multiply by -3. This would be a great place for you to pause and think for a second. Maybe have somebody in the class explain what they think as far as why we're multiplying by -3 instead of regular 3. All right, so if you figured that out already, good job for you. Negative times negative will make positive, and we need to be solving for x. We don't want to have that leftover negative x. There's your explanation. 2 times -3 is -6. Because we multiplied by -3, we multiplied by a negative, this inequality has to turn over to be the other way. So x is greater than -6. -6, -5, -4, -7, -8. Open circle, it can't be -6. Over here, this is the numbers that are bigger than or greater than -6, so off we go, over and to the right-hand side. Okay. We have another group on your next page that we need to handle. So let's handle those. In order to undo subtraction, you add. So hopefully you're thinking, oh yeah, I would add to both sides. So this one's not too difficult. A is greater than 10. Once again, on your graph, 10, 11, 12. You should be doing these right along. Probably a little bit easier for you to actually do them than to be looking back and forth at this point for some of them. So if you get ahead, that is not a problem. So we have an open circle here, and it's all the numbers that are on the bigger side of 10. 11 is greater than 10. 12 is greater than 10. So that should make some sense. Okay, next one. Maybe you're thinking, okay, how do I get rid of a multiply? You do the inverse, so you divide both sides by 4. We're dividing by positive 4, so nothing has to change as far as the direction of the inequality. C is greater than or equal to 3. Okay, so before I actually spill the beans here on why or what, whether we have an open circle or a closed circle, think it through. Hopefully you all settled on it's got to be a closed circle because this means or equal to 3. C is greater than or equal to 3, so 4, 5, all these down this way. Fractions. You should remember how to handle fractions. All right. I know from experience, I say, what do you do to both sides? And people generally say, divide by 2/3. And I say, well, yeah, but what does divide by 2/3 look like? And then someone will inevitably, hopefully say, multiply by the reciprocal, which is actually correct. You need to make sure that you are used to multiplying by the reciprocal because you want to be able to cross cancel. In any fraction things, you need to be able to cross cancel. Now, last chapter I was allowing calculators because there was a lot of difficult calculations, not so on this chapter. This chapter, I want you to put those calculators aside so that we can focus back in again on things like cross canceling because they are super important for you to be able to do the mental math type of things. It saves you time, believe it or not. It's faster to do that than use your calculator. Okay, we have x is greater than or equal to, did not flip because I multiplied by positive 3/2. Put this over 1. 2 goes into 12 6 times, so I can cancel that out. Negative 6 times 3 is negative 18 over 1. 1 times 1 is 1, and that's just negative 18. Make sure that you're heading in the right direction with these. Negative 18, negative 17, negative 16. Think open or closed circle. It is closed, and it's all the numbers that are on the bigger side, so heading this direction. Okay, finally, we're trying to get rid of this one, trying to get rid of a negative 3/5. So to get rid of that, we're going to do negative 5/3 times both sides. So negative 5/3 because negative times negative makes positive. So I'm left with x. 3 goes into 15 5 times. So I have negative 25 over here. Because I multiplied by a negative 5/3, the sign flips over like that. And we put our number line in to be heading in the right direction. Open circle, it can't actually be negative 25, but it has to be on the less than or smaller than side. Okay. All right, so we've looked at our regular problems. We've used the properties, back to the properties. Paraphrased again, adding the same thing to both sides will not change the inequality sign. Multiplying will not change it as long as you're multiplying by a positive. If we multiply by a negative or divide by a negative, it flips over. But the lesson would not be complete if we didn't address the idea of word problems. You will encounter several word problems on your assignment. Use the same idea that we talked about yesterday with the at most, at least, those type of things. And create inequalities. Same rules apply as far as figuring out what variable you're going to use, labeling it, and then actually spending the time to solve the inequality. And then make sure that when you give your answer, it's in words. Okay, so let's think this one through. A rope can safely lift a bucket with a maximum of 18 pounds in it. All right, maximum of 18 pounds. How many pumpkins with an average weight of 3 pounds each can be lifted? So hopefully you're already thinking about what variable. And our question is how many pumpkins? So I'm going to pick P for the number of pumpkins. Notice it's not the weight of the pumpkins, but it's the number of pumpkins. All right, well, it has a maximum of 18 pounds. So that means that you could have 18 pounds. You can't have more than 18 pounds. You have to have less than or possibly equal to 18 pounds. Those pumpkins are 3 pounds each. So since they are 3 pounds each, if I had 1 pumpkin, I'd have 3 pounds. If I had 2 pumpkins, I would have 6 pounds. If I had 3 pumpkins, I would have 9 pounds. If I had 4 pumpkins, I would have 4 times 3 or 12 pounds. So since we don't know how many pumpkins, we have 3 P pumpkins. Yes, I know that probably half of you had the answer figured out before we did an inequality, but you have to get used to writing inequalities. So we'll divide both sides by 3. So P is less than or equal to 6. So how many pumpkins? We have to do a maximum of 6 pumpkins, or at most 6 pumpkins. So no more than 6 pumpkins. Okay, so you have to put into words so that your answer makes sense in the problem. Okay, and one more thing today. Sometimes you have a little bit more complicated to deal with. These look a lot more complicated, but when we start to simplify, we'll find that they are not that much more complicated. So, and a couple sneaked in like this. I wanted to make sure you are prepared to handle them. Don't forget, just like in equations, we want to put our like terms together first on one side. I don't change the signs when I do that. So 7x minus 5x is 2x. I still have my plus 15. I have not done anything but make these simpler. 3 times 5 is 15. Now, I want to try and get my x by itself, so I'm going to take away 15 from both sides. Yes, you can have a 0 on one side of the inequality. I can divide these both by 2. 0 divided by 2 is certainly legal in math. I get 0. 0 is a number. I know if I asked any of you, is 0 a number? You'd say, yes, 0 is a number. But then for some reason, people get confused when you see actually 0 coming out as a number on an inequality. So I'm fixing that hopefully in your mind right off of here. Just means it's an open circle and it's all the numbers that are less than 0, like that if they said solving graph. All right, so let's handle over here. Hopefully some of you are thinking, okay, well, I would need to distribute first, and that's absolutely right. So let's distribute 2 times 4, 8x. 2 times 3, 6. Minus 8x. Let's put like terms together. 6x minus 5x is x. 8x minus 8x is no x's, 0x, so that's gone. And I'm left with just negative 6 here. So that one kind of figured itself out. So we have negative 6, negative 5, negative 4, negative 7, negative 8. So greater than 6 if we needed to graph it. All right, you are now prepared to work on the assignment. So what you would need to do for the rest of the period is work on that assignment. See how much of it you can get done before you need to go home, and everybody have a very blessed weekend. Do something to honor God and do something to encourage your family and be thankful. Bless you. Bye.